Very good day to all. Today we are going to have a revision session for Chapter 3 about the simulation of reactive processes. So the best thing that we can do revision is actually going through some case study. So we have the case study 1 here. Crude glycerol can be converted to a value-added product, 1,2-propanediol. And the glycerol is first dehydrated to acetol, and then subsequently acetol is hydrogenated to 1,2-propanediol. So the reactions involved are given as follows. So you have equation 1 for the dehydration of glycerol, and equation 2 for the hydrogenation of acetol to produce the desired product, which is 1,2-propanediol. So the feed here, we have the crude glycerol, consists of 70% of glycerol and the balance of water. So crude glycerol is fed to the system with a flow rate of 1 kmol per hour, and it is then mixed with 5 kmol per hour of hydrogen before entering the reactor. So the feed temperature and pressure are 200 degrees C and 1 bar respectively. The reactor is operated at the same condition with the feed. The resulted glycerol conversion to acetol is 80%, while the acetol conversion to 1,2-propanediol is 90%. So you need to simulate the reaction using an RTL-RK method and determine the following. A, you have to determine the heat of reaction, and B, you have to determine the selectivity of 1,2-propanediol. Before we solve the problem, let's analyze the problem. So of course, if you would like to simulate the process, you have to know what are the components involved. So here, obviously, based on the description of the problem and also the chemical equation given in the problem, so you need to include glycerol, water, acetol, hydrogen, and 1,2-propanediol. Whereas the property method recommended is NRTL, RK method, and the feed information here, as given in the question, the number of feed, you have 2. Feed 1 is basically the crude glycerol at a feed flow rate of 1 kmol per hour with the composition of 70 weight % of glycerol and 30 weight % of water. While feed 2 is pure hydrogen with a feed flow rate of 5 kmol per hour. So in terms of reactor information, type of reactor model. So this may pop up in your mind when a question regarding reactive processes is given to you. So as in Chapter 3, we have learned several models for the simulation of reactor. So we have learned R-stoid, R-yield, some kinetic-based model like R-plug, RCSTR, and also equilibrium-based models such as R-equal and also R-Gibbs. So in this case, based on the information given in the question, the conversion is actually given in the question. So based on these hints, we know that R-stoid should be used as the reactor model to simulate the process, right? So we move on. Second point here is a valid phase in the reactor. So based on the feed condition here, which the temperature is 200 degrees C and 1 bar, we know that it is actually in a vapor liquid form, okay? Because the boiling point of glycerol at 1 bar is actually more than 200 degrees C, right? So going to the last point, the reactor operating condition, as mentioned, is the same as the feed. Let's solve the problem. So as I mentioned to you, first, of course, you have to create a blank simulation in Xpen Plus, and the first page that you will be guided to is the list of components. So you have to select the components involved in the process. So as mentioned just now in the problem analysis section, you have to list down all the components involved over here. So the best practice here is you have to give the component, just include the component in the third column, and then only you set the component ID later on. So we go to the next page. Here, yeah, of course you have to select property method. Not very challenging because method is given to you. You don't need to make your own decision based on some references. So the method recommended is NRTL-RK. Okay, you just need to first, of course, in order to see NRTL-RK, you have to change the method filter here to all. Then only the NRTL-RK will be listed down under the base method, right, for your selection. So once you have selected, then you have to make sure you click the run button to generate the properties for all the components involved in the process until you get the results available status at your left bottom here. Okay. So once you have this page done, you can shift to simulation tab. So this is a simulation tab. You just need to click here, the simulation tab. Then you will be guided to this page for you to construct the flow sheet. So here, as in the problem analysis just now, we have to use RStoid. So what you need to do is from the model palette, go to reactor and then select RStoid as the reactor model. After that, you have to connect your RStoid with the stream. So as mentioned, you have two feed, S1 and S2, and you have one product stream, S3 over here. Okay. S1 is the crude glycerol and S2 is the hydrogen. Okay. Then you can actually click next. Okay. Once you have constructed the flow sheet, then you click next. So you'll be guided to a page for you to include your feed information. So first you have to put in the feed 1, which is the stream S1. As given, the temperature and pressure are 200 degrees C and 1 bar, and the molar flow rate is 1 kmol per hour for the crude glycerol, and the composition of this crude glycerol is 70 weight% of glycerol and 30 weight% of water. So bear this in mind. Please choose mass fraction because it is given in weight%. So next, then is the page for you to include the feed information for S2, which is pure hydrogen. So in this case, as usual, the temperature and pressure are the same with the crude glycerol, but the feed flow rate here is 5 kmol per hour. And in terms of mass fraction, the section on your right, you have to put 1 for the hydrogen. Okay. So let's move on. Of course, in order to move on, you have to click the next button if you don't know where to go. Okay. So this page is for you to include the reactor operating condition. So it's the same with feed, 200 degrees C and 1 bar, and the valid phases here, as we analyzed just now, is vapor liquid, right? So the next page under the reactor setup, okay, this is the next page, is for you to include the chemical equation. So as given in the question, we have two reactions here. The first one is the dehydration of glycerol to produce acetol. So the acetol will then be hydrogenated to produce 1,2-propanediol. So the conversion is given 80% and 90%, but you have to put in a fraction basis. Okay, so this is the stoichiometry. Okay, this is stoichiometry. Make sure the stoichiometric number for the component is correct. That means 1 mole of glycerol is producing 1 mole of acetal and 1 mole of water. So in order to create a new chemical equation, you just need to click new and put in the component and stoichiometric coefficient accordingly. Okay. So next, this is a page for you to enable the determination of heat of reaction using R-Stroid. Okay. So what you need to choose here is under the calculation type, you have to choose so that report can be calculated for the heat of reaction. Okay. Then at the bottom here, reference condition, you have to choose the reference component for the first reaction and also the second reaction in order for the heat of reaction to be calculated. So the reference component here is always the reactant of the reaction. So for the first reaction is glycerol and the second reaction is acetal. So once you have chosen the reference component, then the reference temperature and reference pressure as well as the phase will be chosen automatically. Right? So with this, we can now run the simulation because we have enough information. So once you have run the simulation, just click the run button either here or here, then the results will be generated. So you can go to the block R101, the reactor block. So under results, then you can have the heat of reaction for the first reaction as well as for the second reaction. This is for you to answer question 1. Okay. So for the second question, you are asked to calculate the selectivity of the 1,2-propanediol. So in order to do this, you can actually use the molar flow rate of the propanediol in the outlet stream, and also the molar flow rate of the glycerol in the inlet and outlet stream. So this is the equation. The equation is given in the box up here. Okay. So we have selectivity of 1,2-propanediol is equal to molar flow rate of propanediol in the product over the molar flow rate of glycerol in the feed minus the molar flow rate of glycerol in the product. So if you include the number accordingly from the stream results, these are the stream results, just extract the information and put into the equation, and you can obtain selectivity of propanediol of 90.4%. So this is the answer for second question. So before we proceed to case study 2, we stop here for a while before we continue. Thank you.